Hi, and welcome to this episode of The Art of Multi-Site Kubernetes. Today, we will be stretching a Kubernetes cluster across different data centers that has persistent storage attached. So here you can see that I've stretched a single Kubernetes cluster across these three data centers, data center 1, 2, and 3. So as you can see, I have a control plane node on each site, which means that whichever site I lose, there's always going to be two control plane nodes left in the cluster, which means a majority of nodes, which means the cluster will survive. Furthermore, I have worker nodes. So as you can see, worker node 1, 2, and 3 on data center 1, and worker nodes 4, 5, and 6 on data center 2. So for reasons around the storage, I don't have any worker nodes running in the third data center because this storage needs to be stretched across as well. And usually you're stretching across two data centers, right? You're building a mirror or a metro between two data centers. So that's actually what we're doing here. So you can install the CSI driver here. The CSI driver will talk down to the storage array. And in this case, of course, we have two storage arrays. So you need to install the CSI driver, and you need to install, well, usually you install two instances and you might pin them so that they each run in a different site. You have to do the same thing for CSM replication. So we're gonna have the container storage module called replication installed within the cluster as well, which makes sure that the CSI driver understands that there's two storage arrays in a mirror configuration. So yes, there's a mirror configuration going on here. So these two are kept in mirror. I'm specifically not saying mirror. So I'm specifically not saying replication, because for replication, when I create a LUN here, it's being replicated here, which means this side will be read-only because it's being replicated. So a mirror is slightly different. In a mirror configuration, with whatever volume I create, you can read and write from it in two locations. So what you're basically doing is you're taking a volume and you're stretching that volume across two sites. Now, if I were to have a container here that wants to use the storage, it is capable of reading and writing to this volume. Now, if I took out this container and I were to create the same container over here, I could access the same storage and read and write to it, even though I'm in the other data center. So it is read-write enabled for both sides at the same time. Of course, it's not a multi-writer setup, right? So this is purely about a single writer setup, but the container could live on both sides or any of the two data centers, and it would have access to read-write enabled storage, which is pretty cool because if this side were to fail and container 1 gets restarted over here, guess what? Yep, you're just accessing the same storage. There's no failover to do within the storage. So this is really attractive to a lot of customers. You only have a single Kubernetes cluster, so you just you deploy it somewhere. It runs left or right. It can fail over to the other side without having to think about the storage. And whichever side it runs, you can always access the same volumes on both sides. So this is very interesting, and it sounds very appealing because it sounds radically simple. But in fact, it's not that simple, right? So even though you may have on this side a witness running, so yes, because it's a metro configuration, we too need a majority of nodes. So from a storage perspective, the witness will have to check out these two arrays to make sure if there's a failure, they can use the witness to determine who's become isolated and who is not, because otherwise you're risking split brain. So that complicates things a little. What complicates it even more is that any volume that you create on this pair always has a preferred and a non-preferred site. Now there are failure scenarios where the storage arrays are unable to determine who is in isolation and who is not. When that happens, they will fall back to their default, which is called preferred site and non-preferred site. So every volume that's created has a preferred site and a non-preferred site. So when you deploy, for example, container 1 here, you may want to deploy it on a volume that is preferred write. Because in the scenario where it can't figure out what is what, the non-preferred side will go to read-only to avoid split brain. So you better make sure that your workload is running on the same data center as the preferred side of the volume. So that complicates things a bit more, right? Now you need to pin your containers. If you have multiple instances, you want to pin them, like half of your instances you want to pin to this data center, the other half you probably want to pin there. But then the backing volumes that they require, they need to be preferred on the correct side. So it seems very simple, but in the end, we see lots and lots of customers that are like, yeah, this is really cool. It sounds really simplistic, but in fact, it is so complex and hard to do at scale that they actually fall back into not so much the stretching, but the severing. So having two separate Kubernetes clusters, you can forget about site number 3 in that case. You just have two different Kubernetes clusters, replication going on between storage arrays, and a controlled failover. Because in this scenario, any hiccup to the system will automatically create a response from the system. And that's a good thing. The bad thing is, whenever something happened, it will trigger an automated response. So the good part is also the bad part, right? Because in some cases, for example, if there's a hiccup in the networking between these two, you don't want all kinds of actions to start, right? You may want to just sit there and wait for a second to determine what is wrong. Maybe there's nothing wrong. So the other scenario where you're severing will give you the opportunity to give you a button that says, now I want to fail over, or maybe I just don't want to fail over just yet because I think that one of the data centers may actually come back online in any second. So this is stretching, right? Compared to the other world of severing two Kubernetes clusters where you have replication going on. There's some pros and cons. You can read about it in the blog posts that's with this video. And for now, thank you for watching, and please watch the next one. Bye-bye.